Hello students, welcome to Sri Jayendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 7 of a unit motion in a straight line. So let's begin with today's class. In previous class we were discussing with the graphs and we have already discussed that there are two major parameters to understand the graph. One of the section would be the slope that we have already discussed in the previous class, and the another section would be the area. Today in this class we are going to discuss about the area of a graph. But before we go to the area of a graph, let's just summarize the slopes that we have already done in the previous class. Look at this. This was the y-axis, this was the x-axis, and we have a different patterns of the slope. In the first pattern, if graph is look like a situation 1, then I can say slope is a constant. If it is a second situation, I say a slope isn't constant, but it would be having a negative value. If it would be a third situation, then I will say that slope is 0. If it was the fourth situation, then I will say slope is infinite. If it is the fifth situation, then I will say slope is increasing. And if it is a sixth situation, then I will say that m is decreasing. I will keep remembering you these things because this is very essential. There are certain topics in physics that does not involve in the any single unit, but they involve with the class 11 and class 12 throughout. There are certain topics that we need for class 11 as well as class 12, such as differentiation that we already did. Next is the graph. In the next coming sessions, we are going to discuss about the integrations. So these are some of the topics that we require in 11th and 12th. That's why revision of this topics is very essential. So please do revise that. Okay, so this is all about the slope. And we also know that there are three ways to find out the slope. What are ways? Yes. First is the delta y by delta x. Next would be the dy by dx. And this is first approach. This would be the second approach. And what is third? Yes, you are right. It's a tan theta. So these are three approaches to find out this loop. So this is what all we require. Okay. Now let's begin with the area of a graph. Consider the situation very carefully. Let's say this is y, this is x, and the graph of quantity y versus x can be plotted something like this. Let's say this is the length of a triangle and this is the breadth of a triangle. If this is the length, this is the breadth, and I need to find out area of triangle, sorry, area of a rectangle. Now you know, sir, this is very easy. Area is equals to L into B. Yes, you are quite right. That area must be is equals to length into breadth for a rectangle. So what I can conclude, what I can conclude from here is that if I need to find out an area, I should multiply quantity on y-axis with quantity on x-axis. This is what This is all what we require. That if I need to find out an area, I need to multiply quantity on the y-axis with the quantity on x-axis. Are you clear with this? Are you sure? Okay, let's look. What could be the situation for us? Let's say, suppose, graph of speed versus time is given. Graph of speed versus time is given. And they have given the situation something like this. Let's say this is 0. This would be the 10 seconds. So time would be in second. And let's say the speed would be in meter per second. This is 10 meter per second. And what you need is you need to find out distance traveled by an object. You need to find out distance traveled by an object. Now think, do we have do we have any relation which can relate speed, distance, and time? The answer would be yes, sir. We have this. Speed should be is equals to distance divided by time. That means distance should be equals to speed multiplied by time. So here to find out the distance, I need to multiply speed with the time. I need to multiply the speed with respect with time. And if I need to multiply this according to the graph, according to the graph, I need to find out area of it. I need to find out area of it. So if I need to find out an area of it, what it would be? Tell me. So distance should be is equals to area of this. It is a 10 by 10. So this is 10 cross 10. That would be equals to 100 meters. This would be the answer. Isn't it very easy? Isn't it? Yes. So let's move to the next. Let's say we have been given that this is velocity. This is time. Velocity would be in meter per second. Time would be in second. You and the situation would be something like this. Let's say this is t and this height is v. I have been asked that find out area of the given graph. This is what they have asked. What should I do? So first thing what I need to do is which quantity will be given after finding out an area. So let's write it down that I know that velocity would be displacement divided by time. So this displacement will be equals to velocity multiplied by time. Are you sure with this? So displacement would be the area of given graph. Displacement would be the area of given graph. Let's say, suppose I represent displacement. Suppose I represent displacement as in delta x. then it should be area of this graph. So area of this graph, it's in triangle. So for the triangle, area could be given as half multiplied by base multiplied by height. I'm sure you know this. So this is in our situation, it is half multiplied by base, it is a t, multiplied by height, it is a v. So it is half into v into t. This is velocity. Yes, got it. Okay, let's move to the next. Let's suppose we have given the situation that this is the acceleration. This is the acceleration. This is the velocity. This is meter per second square. This, so this is the time, and this would be the second. And I have given something like this. That let's say again a triangle is given. This is time t, and this pick is the a. They have asked me that find out area of given graph. Now tell me, which quantity will it be? Which quantity will it be? Yes, you assume it correctly. That acceleration is equals to change in velocity divided by time. So when I multiply this two, what I am having is change in velocity. You should consider that this is not in velocity itself. This represents change in velocity. So change in velocity, let's write it as in delta v, would be is equals to a, that is an 4 acceleration multiplied by t. So this delta v should be is equals to a into t. So if I need to find out delta v, then it should be look like 1 by 2 into t multiplied by a. This is change in velocity. Yes. Are you sure with this? Are you? Will you be able to solve this? Will you be? Okay, so let's summarize the things. Whatever we have done up till now. Whatever the things we have done up till now. Let's say a graph is of speed versus time. So its area, if I take a area of this graph, it would be a distance. And you can easily find out the magnitude of the graph that I'm sure for this. If the given data is, let's say, velocity versus time, then then area of this graph would be the displacement. Next, graph is for if graph is for acceleration versus time, then area of this graph will be change in velocity. Area of this graph will be the change in velocity. Have you done up till this? Are you sure? You want to revise these things? Let's have a look. And if you wish, you can write it, but do it very fast. That If graph is of speed versus time, what I am having is distance as an area. If graph is of velocity versus time, what I am having is displacement as an area. If graph is of acceleration versus time, then area of this graph will give me a change in velocity. Are you sure with this? Will you be able to solve this? Okay, consider one thing. Let's say I have been given a graph. Let's say I have been given a graph of distance versus time or displacement versus time. Then I have given a graph of speed versus time or velocity versus a time. And next, let's say I have been given a graph of acceleration versus time. Now listen this trick very carefully. This will be very important to us. Listen this very carefully. This will help us. If I have been given a graph of distance versus time and I need to find out, let's say, speed. If I have been given a graph of speed versus time, and let's say I need to find out the acceleration. So while a given data is distance versus time, and I need to find out the speed versus time, what I require? Do I require an accelerate? Do I require an slope? Or do I require an area? What would be your answer? Tell me. Yes, you are right that speed is the distance by time. And when we divide the things, we require a slope. So slope is required. Let's say we have been given a speed versus time and we need to find out the acceleration. What would be your answer? What would be your answer? Yes, you are correct. I need to find out the slope of the graph. A same situation is there. Let's say I have been given a graph of displacement versus a time and I need to find out the velocity. I need to find out the velocity. So I need to find out the slope. Let's say I have been given a graph of velocity versus time and I need to find out the acceleration. So I need to find out the slope. Is it clear up till now? Are you sure? Are you sure? Are you sure up till now? Okay. Let's look at the one more thing. Suppose I have been given a graph of acceleration versus the time. Suppose I have been given a graph of acceleration versus time and I need to find out whether it would be a change in velocity or it could be a speed versus time. What I require? What do I require? Think in your mind. But let me ask you one more question. Suppose you are given a graph of the speed versus time and you require to find out the distance. You require to find out the distance. What you should do? You should find out slope or should you find out the area? Think in your mind and tell me. Yes, what was your answer? Yes, you are absolutely correct. You need to find out an area. You need to find out an area. Have you done up to this? Are you sure? Confirmed? Yes. So let's summarize these things. If you want to move forward, then you need to find out this. This is what I call as in forward. This is first step. This is second step. This is third step. So if you want to go from 1 to 2, 2 to 3, move forward. That means I mean to say 1 to 2, 2 to 3. You need to find out this loop. Next, if you want to move backward, if you want to move backward, you need to find out the area. When I say backward, I mean from graph 3 or situation 3 to situation 2, situation 2 to situation 1. Can you understand these things? So now just visualize these things. Just visualize it. Close your eyes and try to remember what I said. Let's say you have been given a graph of displacement versus a time and you need to find out the velocity. What could be your answer? Yes, you are sure. Are you sure? Yes. Yes, you require to find out this loop. Let's say you have been given a velocity versus time and you need to find out the displacement. What can be done? Shall you move forward or backward? Yes, backward. For backward, what could be the situation? What could be the done? Yes, you need to find out an area. Very good. Now let's listen one more situation. Suppose close your eyes, close it, and just assume it that on a very first stage it is distance versus time or displacement versus time. On a second, it is speed versus time or velocity versus time. And on a third, it would be an acceleration versus time. Let's say you have been given a graph of an acceleration versus time, and you need to find out the velocity versus time. Will you move forward or backward? Yes, backward. For backward, what could be the done? Slope or area? Yes, you are sure. Are you sure? Are you? Yes, you need to find out an area. Any one of you was assumed that it would be yes, no. Well, you learn this. Next, a last question. If you have been given a graph of speed versus time, you need to find out two things. First, you require an acceleration, and second, you require a distance. Now tell me, go behind the question one by one. First question, speed versus time, and acceleration is required. Shall you move forward or backward? Yes, forward. If you move forward, what would be the situation? What would be the situation? Yes, it would be the slope of a graph. Now go through the second question. It is a speed versus time and distance is required. So if speed versus time graph is there and distance is required, shall you move forward or backward? Yes, and then backward. If you move backward, what you need to find out? Yes, you need to find out an area. So are you done with this? Will you be able to solve this kind of questions? Will you be? Yes. I want to add one more thing. I want to add one more thing to here that if we multiply quantities of y-axis and x-axis of a given graph, we need to find out an area. We need to find out an area. This is first. And second, if we divide quantity on the y-axis with x-axis, if we divide quantity on y-axis with x-axis, then we need to find slope of. So if we multiply, you should focus on this. If we multiply quantity on y and x on a given graph, what we require is we require an area of that graph. But if relations tells me that I need to divide these things, I need to divide these quantities, then I need to find out the slope of an area. Have you done with this? Are you sure? Are you sure? So let's jump to the numericals of this section. Suppose you have been given this here, given that this is question. This is velocity versus this is 5 seconds. This is meter per second. This is 20. You have been asked that find out displacement of an object. Find out displacement of an object. So at a very first choice, what you need to consider is just close your eyes and imagine that which graph I have been given, it's in velocity versus time. What I require displacement. Will displacement would be there on a forward side or on a backward side? Yes, you assume it correctly. It is on backward side. If it is on backward side, what should I do? Do I need to find out a slope or do I need to find out an area? For backward, it would be an area. So if I find it out, the area of this, it would be 20 into 5, and this comes to an 100 meter. This would be my answer, and this is absolutely correct. Yes, are you done with this? Are you sure? Will you be able to solve this kind of questions? Will you be will you be able to solve this kind of question? Are you sure? Okay, let's move on. Let's say this is velocity. This is time. This is 0. This is, let's say, 5 seconds. This is, let's say, 10 seconds. This is 10. It's a meter per second. Even this is 10. You have been said that find out first displacement and second distance of given graph. Now take a 10 seconds of time and find it out what you should do. Yes, time up. What should you do? What was the situation? What was the situation and what you should do? First thing that what you need to find out. You need to find out displacement. How will you do it? Yes, you need to find out an area, but here two triangles are there. This is area 1. This would be the area 2. So to find it out an area of this, I need to find out these two areas. Let's first write it down the value of this areas. So if I write an area 1 as it is a triangle that you know half into base into height. This is 1 by 2 into 5 into 10. That comes to an 25 units. Area 2, it is an half into, again the same data. This is 5 seconds, this is 10 seconds. So this base it's 5. It's a 1 by 2 into 5 into 10. Again this is 25. Yes. So this is area 1 and this is area 2. Now what you require to find out the displacement. You require to find out the displacement. Now tell me one thing. Can displacement have a negative value? Yes or no? Or rather, I should ask that displacement can have a negative value? Yes or no? Yes. So as I know that, that displacement can have negative value. So its answer, the displacement would be A1 minus of A2. Now a same question I will ask for the distance. Can distance possesses a negative value? Is it? Or distance could be either zero or positive only. What would be your answer? Yes, distance can have only positive values. So distance would be A1 plus A2 because distance could not be a negative. So always remember this thing. I would like to repeat it. Always remember this thing that whichever the quantity they have been asked, don't think that this is velocity versus time, this will give me a displacement only. No, 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 it is not correct. It can, the area of this graph can give a distance as well. We don't know that particle has changed its direction or not. We don't know about this. So if they have asked the displacement, what you can consider is that the quantity that has been asked, does it have a negative value? If it is having or it can possess a negative value, then an area above the x-axis, this is area above the x-axis and area below the x-axis, should be subtracted because one of them would be having a positive value and other one having a negative value. So answer of those quantity which can have a negative value would be the A1 minus E2. Yes, but if quantity has been asked, if certain quantity has been asked which cannot possess even negative value, it can possess only a positive value. Let's suppose a speed has been asked and acceleration versus time graph is given. Same would be the situation that speed cannot be negative. If it is there, it would be a positive only. So in this cases, you are going to simply add these two areas. Are you sure? Yes, are you sure with this? So let's find it out the answer of this questions. Let's find it out the answer of this questions. My first question was the displacement. So displacement delta x would be equals to area 1 minus area 2. As area 1 would be of 25 units, area 2 would be of 25 units, so this would be the 0, obviously, meter. Now what about the distance? What about the distance? This was the second question. Let's say this is delta x should be is equals to a1 plus a2. Here I am going to talk about the distance. Area 1 having a value of 25, area 2 having a value of 25, so this would be the 50 meter. Yes, this is the 50 meter. So are you sure with this? Are you sure with this? Here the thing here the thing could be, if a particle has started from a certain position and it landed up on the same position. It landed up on the same position. So it if it is landed up on the same position, what you need to do is you need to just consider that whether my quantity can possess a positive value or only, or positive value and negative value both. If it can have a both positive value as well as negative value, just subtract the area 1 minus area 2. But if can have only a positive value, just add it up. So are you done with this? Ready for the next question? Are you? Let's move on. Do you know the work done? Are you? Do you know the work done? Are you sure? So let's find it out. Suppose this is work done or this is force, this is displacement. This force is in F and this displacement is in X, and you've been given that something like this. What is it? Which shape is it? Which shape is it? Yes, you are correct. It's a trapezium. Let's say this is 0, this is 2 meter, this is 5 meter, this is 7 meter, and this is a force of 10 Newton. And the question is find out work done on the object. You need to find out the work done on an object. Now, what could be the situation? I know that work done would be equals to force into displacement. So work done is equals to force into displacement. Now, when and when you need to multiply, look at here. This is the sign of a multiplication. Yes, what you should do? Tell me what you should do. Do you need to add? Do you need to find out a slope, or you need to find out an area? What should be done? What should be done? Yes, you need to find out an area of this. Now, how can you find out the area of this? How can you find out an area of this? What could be the options? Yes, one of the option would be divide this into one of the triangle. Second, divide this into a square, or it would be a rectangle. And this is the third. So my area 1 should be 1 by 2. It's in half into base. This is 2 multiplied by height. It's a 10. So this would be the 10 units. Find out the A2. This rectangle started by 2, ended by 5. So it would be a 3. 5 minus 2 would be a 3 into 10. So that would be the 30. And the third started with 5, ended with the 7. This is area 3 would be equals to 1 by 2 multiplied by 5 to 7. This is 2 multiplied by 10. So this is again 10. You can even use the direct formula of the parallelogram of the trapezium. You might know that. So final work done would be equals to A1 plus A2 plus A3. And if I add up this three, it is 10 plus 30 plus 10. So 10 times 20, 20 plus 30. This is 50. What is unit of work done? What is it? Yes. Or anything else? Any other unit? Any other unit? Yes, it's a Newton into meter. So you can write like this. It's a 50 joule or Newton into meter. Are you sure with this? Are you? Now let's look at the next question. Let's go for this. If the data is something like this, this is force and this is displacement x. This is 0 meter. This is let's say 5 meter. This is let's say 10 meter. This would be the 10 Newton. Again, this would be the 10 Newton, but as it is in negative side, it would be represented as minus 10. You need to find out work done. You need to find out work done on the given graph. How can you do this? How can you do this? So what you need to do is first, do you have any relation for work done, force and displacement? Yes, we did it in previous slide only. It's a force into displacement. And when I need to multiply, I need to find out an area that I know. So what you need to do is you need to find out an area one. You need to find out this area. This is an area two. Let's say this as an let's say this as an 20 meter. And so you need to find out an area one and you need to find out an area two. So would be the what would be the value of an area one? It is a rectangle having side 5 by 10. So this is 5 by 10 would be equals to a 50. And what would be the area 2? What would be the area 2? This is beginning with the 5, ending with the 20. So it would be a 15 multiplied by 10. So if I multiply 15 by 10, it would be an 150. Now the final question arises. Do I need to add this 2 or shall I subtract this 2? What would be your answer? Tell me. Shall we add this or subtract this? So for this answer, we must consider that do we have a negative work done? Do we have a negative work done? Yes, we absolutely can have a negative work done. And when work done can possess a negative value, I can write like this. So work done should be is equals to A1 minus of A2. So this would be a 50 minus of 150. This is equals to minus of 100. This is the work done. Now, think this. I have purposefully taken this numerical of work done. First, tell me, work done is a scalar or vector? Work done is scalar or vector? Yes, it is a scalar quantity. So maybe, maybe in the previous questions of displacement and velocity, your mind have concluded that if it is a vector quantity, I need to subtract it. And if it is a scalar quantity, I need to add it up. It is not the same thing. Yes, it is just the false conclusion that you have derived from this question that it is a displacement. Displacement is a vector quantity, and that's why I need to subtract it. It is a distance. Distance is a scalar quantity, and that's why I need to add up. It is not the case. I shall repeat this. I repeat this because I want that there should not be any misconception. Work done is a scalar quantity. Even though work done is a scalar quantity, it can have a negative value. And when it can possess a negative value, it can possess a negative value, those areas which are below the x-axis should be considered as a negative, and those areas which are the above x-axis should be considered as a positive. I hope you are clear with this. Are you? So you don't consider that whether it is a scalar or vector. You need to find it out that this can be having positive value or negative value. If it can possess both, then it area of it below the x-axis would be a negative and area of it below above the x-axis would be a positive. But if it can only contain a positive value, if it can contain only a positive value, then you need to add it up. You don't bother that whether this area would be above the surface or above the x-axis or below the x-axis. You just add it up. In the case of a quantity can have only a positive value. Are you sure with this? Comfortable with this? Are you sure? Let's go for the let's go for the last question of today's section. You have been given force and time, and it looks something like this. This is 0, this is 5, this is 10, this is 20. Force is in Newton, time is in second. And you have been asked that. Find change in momentum of an object. You have been asked that find the change in momentum of an object. So, do we have any relation? Do we have any relation? If you don't have it, just do rough calculations. You might find it. In back of your mind, you should think like this. That force should be is equals to m. This is equals to m into bracket v minus u by t. So that would be mv minus mu by t. This is f. So if I multiply this two, if I multiply f into t, it would be a change in momentum. This is the rough work of your mind, not even on paper. You must know this. As a class 11 student, you know that f into t should be is equals to mv minus mu. But if you don't worry. Just remember from next time. Okay, so let's move on. So the thing is, I need to multiply this two. It is mv minus of m. And as I multiply, I need to find out an area of this. So change in momentum would be is equals to area of force versus time graph. So if I find out the area, it's in 1 by 2 multiplied by 10 multiplied by height. It's a 20. So this would be the 100. Their unit would be kg meter per second. Their unit would be the kg meter per second. I hope you are clear with this and you find out the same answer. Did you? Okay, great. So let's shut it down. What we have discussed up till now, what we have discussed up till now is all about the area of the graph. So now you know that what is the slope, what is the area. Slope would be there in the last class, area is in this class. In the next session of the graph, we are going to discuss a certain technical parameters such as the graph of a straight line, graph of a parabola, and if two functions are there, how its graph should look like. But before we move to that step, you must be very through with this too. Yes, so please read this very carefully. Go through the class notes again and again, and you will be having a very comfort with these two topics. So please do it. Please do it. Oh, thank you. Bye bye. Take care.